So we're going to shift gears a little bit. We are not going to be talking about any products in this section of the slide, but we're going to be now focusing a little bit around software solutions that we are introducing on all of our Catalyst platforms to really address the megatrends that we saw earlier around collaboration, security, BYOD, all of these aspects. And in particular, what I'm going to be talking about in this session is a technology called Security Group Access, also known in the marketing term as Cisco TrustSec. And I'm just going to quickly zoom in through a couple of slides just to show you at a high level what TrustSec is, what Security Group Access is. And then the rest of the session is primarily going to be whiteboarding around a little bit of technology deep dive on how this works under the layers. So what is Cisco TrustSec or Security Group Access? Essentially, it is a form of role-based access control. Now, when you provide security in your network, in your campus networks, or even across your WAN or in your data centers, you very often use access control lists, which obviously come with their own limitations around how you provision these access control lists. That is, you provision them based on your IP addresses and the way you've structured your network and you've designed it. And obviously that comes with its own limitations around how you can manage these and how you can scale with these. And we often have customers saying us that they run into extensive access control lists, which are so hard to maintain and manage because it really is not very intuitive around how these were actually first of all put in place. Compare that with what we have done here with Security Group Access and providing role-based access control. So what we have really done is we have taken out the topology dependence on all of your access control and made it based on the roles that you have in your organization. And going back to your traditional example of HR, marketing, finance example, you still get the same thing, but now it doesn't matter how your network is, how your VLANs are provisioned, how your routing is happening, how your subnetting, how you've done your subnetting. It doesn't matter. And all of this comes with a centralized point of managing your policies and defining your policies. And it gives you opens up the flexibility to design your network as really the way you want it. And so you've seen that it decouples your security policies from all of your underlying network infrastructure. So this slide again presents at a very high level just how TrustSec works. And the next about 20 minutes, I'm going to be talking to you about exactly how we get this thing up and working. But essentially what you're seeing here is that your traffic gets tagged at the access layer or at the ingress of the source of the traffic. And then essentially we are tagging that traffic all the way through till the time or the place in the network where we actually do the policy enforcement. So think about this, this model is that it is an egress policy enforcement as opposed to an ingress policy enforcement, so that you only have to define policies which are relevant to the switch where the policy enforcement is actually going to happen. So let's go, so that's really all the slides I have for now. And the rest of the session, I'm just going to be doing a little bit of whiteboarding and showing you exactly how we get this to work from top down. All right. Okay. So essentially, there are three components of TrustSec as an architecture. So first of all, what you need to do is determine a context of your user, like who is trying to access the user, and find out what is the role of the user. And based on that, that's how you're going to determine what policies you need to apply. So the fundamental thing here that you need to know is who is accessing the network and what is the role of the user in the organization. And so for that, we primarily depend on 802.1x as the underlying mechanism for accessing or identifying user. The second thing here is that, as you've seen that this we have, okay. So now that you have identified your user, you want to propagate this context information around who the user is all throughout your network. And the way we do that is by using what we call as security group tags. So it's called SGT. So I'm going to throw a whole bunch of acronyms in the solution. One of them is security group tags. So essentially, based on this context, your access switch, which is acting as the authenticator, now is able to assign, tag this traffic based on the user identity. And all of this tagged information is going to get carried out throughout your network, where whatever resource or whatever the flows are there in the network, that the traffic is going to get tagged throughout. And depending on where at the egress, where you're actually trying to access your network resource, role-based access control list is going to be applied based on the tag that is there in the traffic. So that is called as policy that's the policy enforcement piece of it. And the feature that's used for that is called security group access control list. Also known as SG-ACL. So you're going to see this technology referred to often as SGD/SG-ACL, or also Security Group Access SGA, or also known as TrustSec. And now that we are actually propagating all of these different tags throughout your network, you want to make sure that nobody's actually snooping in on these, or like the networking equipment that's carrying this tag is actually authenticated. So we also have this network device authentication, or what we call as NDAC, which ensures that all of your switching infrastructure is also authenticating against each other, and so you don't have any other user trying to plug in a rogue switch and trying to snoop in on your traffic. So that's how you're actually creating a trusted domain of switches, where your switching infrastructure is authenticating against an identity server. So you've got that trusted domain. You're classifying traffic based on the source, so you know who the users are, and you're authenticating them. You're propagating all of that information through your network. And finally, based on that tag which identifies the user, you're able to apply the appropriate role-based policies in your network. Yes?
So these are more in the order of NDAC first, AO2, 1X, producing a security group tag to tag the framework, and then the policy enforcement.
Exactly. Yeah, precisely.
Security group tag is for the users, or it could be for the devices. You can identify all the switches as part of the security group. You can also identify users separately as part of the security group. So it can be separate, it can be same.
So I guess my understanding of the SGT was that it was just like a policy identifier that went in there, not specifically the user. We don't specifically, we're not specifically able to tie a frame to a user. We're able to specifically tie a frame to a policy that a user should.
Absolutely.
Okay.
Absolutely. So the mapping there is you get a user, you know who the user is, you identify the user, and you classify him into a particular role. And you define your tags based on roles, not users.
So is there the notion of I guess trust boundary extension to be able to, if you have maybe some software on your host, your laptop, maybe you're using some MDM software for a mobile device to be able to extend that classification, allow your endpoint to participate in the classification?
So the classification really starts at the access layer switch. That's where the tagging starts. So we really don't have current capabilities to extend
guys
it.
like me. I guess I have .1x over wireless.
Exactly.
I'm making an assumption here. Does this work over wireless infrastructure too?
Yeah, absolutely.
Okay.
Yeah.
Not just .NET, MAC also, you can get MAC address or WebAuth, any other mechanism.
So the biggest challenge I've had getting my mind around the whole TrustSec infrastructure, and I don't know if you're going in this direction or not, but was just understanding, what if my entire infrastructure does not support SGT? What if you have those switches out at this part of the network that doesn't support it?
Yeah.
How do you deal with that?
Yes.
The IaaS component's fairly inexpensive from what I've seen. Building out the end-to-end network is what's expensive.
Yeah, absolutely. And it's going to be a journey. It's not going to be, a lot of networks today are not going to be ready for this architecture. It's going to be, we're going to probably have to wait for a couple of years till the kind of hardware support that we require is actually more widespread. We have intermediate solutions such as SXP, Security Group Exchange Protocol, which we'll talk about later. But again, these are like overlay protocols over existing networks And again, that's something that you have to manually configure and administer. So again, defeats the value proposition of SGT. So essentially,
Yep.
really, if you want to get the full benefits of the solutions, you're going to have to wait a little bit till you get that proper end-to-end support, and then you can actually get the full benefits of the solution.
Maybe afterwards you can point me to a URL or something that shows me how we work when we don't have full end-to-end support.
Yeah.
What works and what doesn't.
Yes. Yeah. So there are some very specific use cases which you can deploy in easier manner, and those can be those are some intermediate solutions we
And I
have.
guess the ASA is on the roadmap with like version 9 or something.
Yes, the AC is on the roadmap for the SXP support. Yes. Yeah. So essentially, the next part I wanted to cover was just show you an. I think we've already covered at a high level what this thing, how it looks. But let me just draw a simple network topology and show exactly the flow of the sequence of events that's going to happen to enable this kind of thing. So let me just consider a simple. You got your access switches here, a simple campus topology here. And then maybe you've got your some data center network here, one of your data center switches here. And maybe I'll just consider a typical example of 2 servers connected here. And let's say you've got a host which belongs to, let's say, a marketing user, and let's say you got like a finance user here. And also in your data center resources, let's say you got a sales database, and let's say you got your web portal. So essentially what you want to do is you want to allow restricted access to your sales database to only the marketing group, whereas, and you want to have like full access to your web portal, whereas you want to separate your marketing and finance users. And that's the kind of things that it allows, security group access allows, all in a role-based manner, irrespective of how you design your network topology. So what's going to happen in this flow is essentially, first of all, we talked about the NDAC part, where you have an authenticated switching infrastructure, which is now able to trust the traffic that is flowing through it. And all of these users are going to depend on .1x to get authenticated. And what about your resources, for that matter, who do not support .1x? Well, you've got things such as MAB to get that support. Or we also have this static mapping. So basically, based on your .1x authentication, these users are going to get tagged into certain groups or roles. And the entity which does all of that is today Identity Services Engine. That's your Radius server, which is connected to all of your network. And based on your authentication, this tag information is going to get downloaded to all of these devices which are directly connected to the end hosts or the resources. So all of these switches are going to get the appropriate tag and role information around who is producing, what's the source of that traffic, what's the destination of that traffic. So now what's going to happen is that when any of these users start generating traffic, this switch is going to tag that traffic based on this particular user based on with the appropriate SGT tag. And so you can see that, let me just draw the tagged traffic flow in red here. So you know that this is all the tags being propagated. So your tag information is propagated all the way till the end device, or maybe as well as this kind of a flow. And you also have you're also going to define your role-based policies in terms of a role-based matrix. So what your matrix is actually going to look like is it's going to be, let's say these are all of your sources of traffic, and you've got a finance group, and you have got you've got your so you essentially define your policies just in a matrix form, which is completely independent of network topology, as you see. And this is where your permissions are essentially defined. So now let's consider an example flow for beginning from your, let's say a marketing user accessing a sales database. What's going to happen is you authenticate a user, you identify the source of information, and you tag the traffic based on the source. And that's why you call it like source group tagging. And this tag gets propagated all the way to the, the egress of the network, where your policy now gets enforced. So what's going to happen is that this switch knows that this flow is directed towards this server, and it knows the destination of the resource that you're trying to access. And based on the tag that's there in the traffic, it also knows what is the source of the traffic, what's the source role of the traffic. And as a result, this switch is able to dynamically download all the policies from your identity services engine, your identity server, to the switch and apply an egress ACL, which is here. And this also applies to any kind of flow, whether you're talking about an access-to-access switch, whether you're talking about segmentation at the access layer, or whether you're talking about segmentation, differentiated access to resources in the data center, or somebody trying to have differentiated access even from the branch environment. All of these, you can manage all of these policies in a single policy definition, irrespective of how many branches you have or how many access switches you have. So, just wondering if any questions or comments about all the things I've covered for now.
So these switches down here that the hosts are connected to, are these all 3750s? Is that the baseline switch that you have to get for this?
Yeah, so it's currently supported in the 3750X and the 3560X.
Okay, so
And then as far as the distribution core is concerned, you have it's supported in the Catalyst 6500 SOUP 2T.
now is this a tunneling protocol? I mean, would you consider this a layer 2 tunneling protocol?
It's not a tunneling protocol. It's actually this tag information is carried in the 802.1 AE header.
Okay.
And it's a of course, .1 AE is standards based, but we are actually using 16 bits of that header as a command field to where we populate this SGD tag.
2960, it's not a software, it's a hardware limitation on 2960.
Yes, yeah, on the 2960 it's a hardware limitation.
So you're seeing a sort of over the next 5 years, as old hardware is phased out and it's becoming the standard. It's not something really deployed yet. It's out and available shipping, but it's
Yes.
not really being seen deployed.
Absolutely, yeah. I would say that there are some lighthouse customers who are doing proof of concepts, and they are seeing the value in it. But in terms of real large-scale deployments, we're still a little way to go till that happens.
And it seems to allow you to break free from the access control lists that are based on subnets.
Absolutely, yeah. That's the whole value proposition of this, and it provides you centralized management and definition and administration.
And I guess when you authenticate, and maybe my understanding was incorrect, but I think when a user authenticates to ICE, and then the device is sort of assessed by ICE, that's when the policy is formed. Is that correct? The user plus the device?
Let me see if I can correct. The way these work is like, let's say user authenticates, EFPL packet goes and then Redis counting message, Redis message go to Redis, so when the Redis authentication comes back, right? When it comes back, it also comes with a SGT tag that shows what is the role of this particular user who just logged in, right? Let's say the user is a financial user. That comes with a tag. That number says, okay, this user is a financial user. The switch at that point knows the IP address of the user and the role that he belongs to. It keeps a map. And from that point on, whenever a packet comes from that particular user, it is tagged with that role ID. That's all it does.
Okay.
It just sends the packet out. And then when it gets to the destination, at the egress switch, downloads policies relevant to the sources that is directly connected. For example, sales server is connected on that particular switch, and it's mapped to a tag based on IP to port mapping. It downloads relevant policies from ICE for that particular destination. That policy will say sales database is a server, and then financial server, users, no access. Marketing users, permit. That's all it has. So when a packet is received at the destination switch, it looks at the packet. The packet now, let's say it comes with the financial user ID, and it is trying to get to a sales server. There is a deny, so it drops the packet.
So how do we get to the point that it's not just Paul Stewart, but it's Paul Stewart that's not on his corporate laptop, he's on his iPad today?
Okay, so
that's one of the value propositions that I've heard as well.
Right,
for
that's where the
this.
context aware comes in.
We not only look at the user login, we also look at the type of device he logs in. We can also look at where he's logging from, location, or we can also look at how he's logging, wired, wireless. We can take all that into account to make a decision as to what is the role of this user.
And at that point, is the SGT changed, or
You
is,
can,
is
yes.
It, okay.
Yeah,
Yeah,
you
it
can create a
depends.
separate tag
So you
for
have,
that.
like, user BYOD device.
Exactly. Yeah.
Yeah.
User
Precisely.
corporate device, user personal device.
Correct.
Yeah.
Yeah.
Think of it like this.
It's
It's
all
like,
just classic tricks you've done in radius servers for the past, 15
Yeah, yeah.
years.
right.
Right.
Yeah, you're just extending it to
Right, the-
Yeah,
the
you
tagging
just- you just
mechanism
use
that's
for
there.
dialer profiles. Right, you'd have someone log in, and depending, their dial back would be held up in the radius server.
Yeah, but
Classic implementation.
you,
That's good.
the thing that you're doing here now is you're actually tagging the frames, and with traditional radius models, you would maybe throw in a different VLAN. Or
Yeah,
something.
exactly.
No, I was actually going way back before that.
so the analogy I would usually give is like your
Profiles and stuff.
your employee badge. When you go get a badge, they just look at your ID and give you a badge saying employee or guest or a partner, right? They don't care about which building you have access to, where you go, and all that. They just simply say who you are, a tag. And then when you get to the destination, they look at your badge and say, okay, you're an employee, you're allowed. Or you're a guest, you're only allowed to certain places.
Sorry, go ahead. Yeah, so are you guys pushing this up into, so you talked about, so you're addressing the problem of, I may have my accounting floor, and some customers may restrict based on, generic
Location.
location or subnet to access to a resource.
Yeah,
based on layer 3, even layer 4 information.
Correct.
And we're trying to get this notion of who I am and what device I'm connecting to, primarily who I am, and using that to filter what server I can connect to. Are you pushing this information up into the content security controls that you have inside ASA right now, to be able to say, you know what, I'm calling, and I'm actually, I can go to Oracle iProcure, and or iExpenses or whatever, and I can put in my expenses, but I shouldn't be going to my Oracle module for the accounting module. Is that there or coming, or?
So the way you would
content filtering based on security policy enforced through, or I guess communicated through tags.
Right, we don't have the content filtering part yet. Support for this one. The way you'd have to do that is primarily allocate separate servers and essentially based on different resources. But we don't have the ability to do yet content filtering based on SGT.
So does this work with like your iron port content filter any at all? Is that on the roadmap? Because
Not
it
as
seems
of yet.
like we're doing a completely separate out-of-band authentication from the iron port perspective.
Yeah. Right, so at least as of now, there are no plans to get both of those integrated, but that's certainly a possibility in the future.
Yeah.
But yeah, that's a valuable feedback. We need to think about content filtering based on SGT tags as well.
Well, my biggest challenge is, and it just came up on the tweet stream, is that, there's this width and breadth of products, and while you guys may be responsible for, making a product in a specific product group or business unit, that, us as integrators and consumers of the products, we actually use all of them.
Yeah.
And, and it's like, okay, you got 5 different things, and technologies that do meet a need. When it's going to work with all the things that have Cisco on the logo.
Yeah.
Right. That's one thing why SGT is not being widely deployed today, because it's an end-to-end solution, not just one BU, right? We can't just come up and say we are HTTP capable. It has to be from ICE, it has to be from ASA, firewall, it has to be from 6K, 4K, everybody.
Yeah.
So that's why it's
and to me the real challenge is building the end-to-end network that supports
Yeah,
this thing.
exactly. Yeah, and that's going to take a while
We're
to
talking
get
about
all that
putting
support.
3750 series switches, connected to a workstation, and we don't have need for that other than the possibility to support this once we get an end-to-end solution built.
Yeah.
right. Once you have this implemented, is the best part. Once you define the policy, you don't have to change it ever, unless the role changes, right? For example, once you define marketing has access to sales database server, that rule never changes.
Right.
But
right.
Yeah.
rather, if you had used the IP address base, then that changes any time.
But it's the
Yeah.
phasing. It's going to take 5 years, or you
Yeah.
got a budget for this. If you really want this, it's going to take a while. Either you're going to rip and replace and do it today and put
Yeah.
3560Xs everywhere,
Yeah.
and rip out all the switches, or
Yeah.
you're going to phase in over 5 years where you wait and plan to use it, or and
Yeah.
then do you have any sort of roadmap to bring it down a tier, because they're pretty high end switches for access layer. Like I know a lot of use 2160, 1 gig, whatever. And
Right.
Are you looking to? Can you bring it down to a lower level?
Uh,
Or is it a
no, it's
hardware
it's
thing?
it's going to be 3560s
Yeah,
and
he-
30,
So when you develop
3750s.
further products, can you bring the? It'd be nice to see a lower price point.
So we have this. So we with the security group exchange protocol that we are speaking about. That is
Yeah.
going to work on the 2960, but that's a software overlay.
Yeah.
Right. At least for the 2960 case, you can transport the information about roles and IP address to the next guy who can do.
Is that a
tag-
performance hit?
It's,
Being a software
it's
overlay?
not a performance hit. It's a hit on your manageability, right? Because you have to manually set up those bindings now,
Yeah.
and so that's the challenge.
yeah,
with
the-
that.
Is that on the roadmap or is that available today?
SXP, it's available today.
Okay.
Yeah.
So
Yeah, SXP is available on
Yeah, that's available
2960
today.
as
It's been
today.
available for a while.
Thank you.
Yeah. So I was just.
Can I ask one question
yeah, sure.
from the Twitterverse where somebody was asking why there was no IF map support for in ISE?
So we are thinking about an alternative to that, and that is on the roadmap.
So
Which
your
integrates.
alternative is on the roadmap or IF map is on the roadmap?
No, IFMap is
Never.
well. I'm not sure because that's not my business unit, so I'm not the person to comment on it. But we are looking at that kind of functionality and that kind of a solution on the roadmap.
All right, thank you for
Yeah.
answering that question.
And so before I wrap up, just want to show you like some screenshots around how we define role-based ACL. So you see that this is an example of an SG ACL policy. And you see that this policy is completely based independent of IP addressing. It's just based on what protocol and what application you want to allow or deny access to. And the way you administer this policy is through this matrix form like I showed you. Let's say you've got an employee who's trying to access an employee surveillance camera. You see that you want to deny him IP. That's your IP SG ACL. As simple as that. And if it's an employee, it's a facilities admin trying to access some surveillance camera, you allow them the web interface to it. You just apply that the permit web access control list. So this is the administration interface for administering and enforcing SG ACLs in your network. So with the single point of management, you can gives you the ability to enforce access control all throughout your network.
Yeah, this automatically gets downloaded to the egress switch, and it gets downloaded only when the egress it finds out that the destination is available. Not like you download all the time, you configure it. It's only downloaded on demand. So that way you save resources, and also since it only has protocols or services, you can also share the same ACLs with other policies. So it considerably reduces your TCAM usage. So you can create your policies.
So this is this is completely Cisco's way of using that field, right?
Yes, yeah, it's a Cisco proprietary solution, but down the road we might be looking at ways to standardize this.
Have you guys submitted any drafts around this to look for standardization?
Not as of yet, but yes,
So years away. Years away.
it's something that
There's a lot of risk.
Yeah, because you're really
Yeah.
you
Can I
guys
ask
your
you
entire
to that?
infrastructure.
Because,
Yeah.
sorry, I just want to jump in. And I'm the 6500 guy. So I actually was just in a CTS engineering meeting. Because there was also the earlier question about, an end-to-end solution. One part that I think was kind of captured in the slides was the layer 3 CTS, right? So you're actually embedding the security group tag in a header and a trailer, which any non-CTS device, be it Cisco that's a legacy device or a Juniper or HP, would just see it as an IP packet, right? So you can still have non-Cisco, non-CTS devices in the middle and still take advantage of these. So I mean, of course we're going to go through and try to work on a standard. We've done it with HSRP and MPLS and all these things, but you can still begin to take advantage of these even now.
Yeah, there are many ways to migrate from existing network. I use the existing network to simply use the technology.
And gain all the benefits of using security group
That's
tags.
just been my hardest thing is to understand,
Yeah.
how it all fits together
Sure.
and continues to work.
Sure, yeah, there's certain use cases where you can actually deploy today. We can go into more detail later.